All right, so today's lesson is going to take what we learned yesterday, which is talking about raising anything to an exponent of 0, and also what to do with negative exponents, and it's going to combine it with another situation here. So what we're going to be looking at today is what happens when you multiply exponents with the same base. So what we're going to look at here is I'm just going to go through some examples here, and then we'll work through some together. So the first thing that we notice here is we know that 8 to the third is that this 3 tells us we need to multiply 8 3 times. So that's really saying that we have 3 eighths. And I'm sorry, this board is being super emotional today. So I've got 8 times 8 times 8. And then I'm multiplying that by 8 to the fifth power. So 5 more eighths. 1, 2, 3, 4, 5. And so then now I have 1, 2, 3, 4, 5, 6, 7, 8 different bases. And 8 to the third multiplied by 8 to the fifth is actually 8 to the eighth because there are 8 eighths. So what you'll notice here is the base stays the same. And the only thing that changes is the exponent. So here, the 3 and the 5 produced our 8 there. So for the next one, I've got 5 to the second power, and I've got 5 to the sixth power. So this is 2 5s here, and this is 6 5s here. And 2 5s and 6 5s is 8 5s, so that's 5 to the power of 8. So that's going to be 2 plus 6, and 2 plus 6 is 8. For the last one there, we have 3, and anytime you just have a normal number, 5, 7, 100, any normal plain number always has an exponent of a 1 on it. So I have 1 3 multiplied by 2 more 3s multiplied by 5 more 3s. So 3 to the first, 3 to the second, and 3 to the fifth. I still have a 3 here, but that is 1 plus 2 plus 5, so that's 3 to the power of 8. So when we are multiplying like bases, the base stays the same. And you add the exponents. So one of the things that can kind of be sort of confusing here is what you're doing is you're multiplying 5 to the second power by 5 to the sixth power. But when you're multiplying those, the only thing that you're doing is adding the value of the exponents. So we're going to look at just these problems. Again, it looks like a lot, it's not a lot. Wait till you see how fast they go because they're just a couple different types. So in the first one here, I have a base of 6 and another base of 6. So if I have the base of 6 2 times, then what I know, sorry again, the screen. So I have the base of 6 both times, and when I deal with like bases, what I have to do is add my exponents. So when I add my exponents here, that's going to be 5 plus 3. And when I add 5 plus 3, I get 8. So this is going to be 6 to the power of 8. Again, I have a base 5 here. The base stays the same. And when I multiply like bases, I add. So 5 plus 7 is going to give us 5 to the power of 12. Here we've got base 4. So when I multiply 4 to the fifth by 4 to the ninth, base 4 stays the same. And I add my exponents. So 5 plus 9 is going to give me 14. So I get 4 to the power of 14. And the next ones here, I've got my base 2 here, and that's going to be, it's going to stay base 2. And when I multiply those like bases, I know that 5 plus 8 is going to give me 2 to the power of 13. So that's sort of the most simple way to look at this. You're just combining two powers that have the same base. So when we look at this next row here, the only difference is that we have a negative on one of our bases here. But what we should remember is that this is actually base 5 to the fifth power times negative 1. So you want to rewrite that as negative 1 times 5 to the fifth power times 5 to the ninth power. So what we can do now is we can combine our like bases. So we still have 5. And then when I multiply my like bases, I do 5 plus 9. So I get 5 to the 14th. But I still have to multiply that by negative 1. So what's going to happen when I multiply that by negative 1 is I end up with negative 5 to the 14th. Here I'm going to have negative 1 multiplied by 8 to the power of 5 multiplied by 8 squared. Well, here I'm going to ignore my negative 1 till the end. My common base is 8, and 5 plus 2 is 7. So I've got 8 to the power of 7. My negative 1 there means it needs to be negative 8 to the power of 7. I'm going to keep going here. So I've got negative 6. I just want to make that negative 1 times 6 to the 7th times 6 to the negative 7th. So again, we know from yesterday that we're not supposed to have negative exponents, but I don't want to deal with that until the very end. I want to see if maybe it goes away when I combine. So here I've got my common base of 6, and when I add here, that's 7 plus negative 7, so that's 6 to the power of 0. Well, now that's being multiplied by negative 1. So I've got negative 1 times 6 to the power of 0. Well, 6 to the power of 0 is positive 1, because we know that any base raised to the power of 0 is 1. So negative 1 times positive 1 is just going to give us negative 1. All right. So again, the last one, like this one, this is going to be negative 1 times 10 to the 8th times 10 to the 9th. So when I multiply 10 to the 8th by 10 to the 9th, my base 10 stays the same there, and 8 plus 9 is 17. So I end up with my negative here, so I have negative 10 to the power of 17. All right, so here we have a situation where we have 3 as our common base here, and some of us might get a little scared because you see parentheses here, but remember, parentheses are just another way to say that you're multiplying. So this says the exact same thing as 3 to the power of 4 times 3 to the power of negative 6. So here we've got our like base, so we know it's going to stay. So now we have to look at our exponents. So we've got 4 and negative 6. Well, we can do what we always do when we have like bases, and we can add our exponents. So when I add my exponents here, I have 4 added to negative 6. Well, 4 plus negative 6 is negative 2. So I end up with 3 to the power of negative 2. The problem here is that you cannot leave an exponent in its final form. Like this can't be the answer because I have a negative exponent. You're not allowed to have a negative exponent, and you're not allowed to have an exponent of 0 when you go to say your final answer to a problem. So what I have to do is I have to do what we learned about on Monday. I have to turn this into a positive exponent using a fraction. So I'm going to put 1 over the power of 3 squared. Well, 1 over the power of 3 squared is the same as 1 over 9. So for this one, your final answer here ends up being 1 over 9. All right, so let's look at this next one. So again, in this problem, you're just multiplying like bases. These parentheses are just saying you're multiplying 7 squared by 7 to the power of negative 9. So because we're just multiplying like bases here, I keep my 7, and I add my exponents. So 2 plus negative 9, we know it's going to be negative because negative 9 is bigger. So 2 plus negative 9 is going to be negative 7. Well, again, I cannot leave that as my answer because that's a negative exponent, so I need to turn it into a positive exponent using a fraction. So that's going to be 1 over 7 to the power of 7. So again, you cannot leave it in that form. When you end with a negative, you turn it into a fraction with a positive exponent. So that would be my final answer. In this one, I'm not going to go into my calculator to figure out what 7 to the 7th power is. As long as the exponent's bigger than 3, so if it's 4, 5, 6, or bigger, you're just going to leave it as an exponent. When we continue here, now we have a base 10 each time, and again, we're just, this thing's so annoying, you just multiply like bases. So you keep your 10 here. Well, this is 4 added to negative 8. Well, 4 plus negative 8 is going to be negative 4. And again, you cannot leave it as a negative exponent, so you have to rewrite it as 1 over 10 to the positive 4th power. And again, because you have a positive exponent there, you're not going to have to, or excuse me, because you have an exponent that's larger than 3, you're not going to have to figure out what 10 to the power of 4 is. All right, we're going to look at the last one in this row, and then we're getting pretty close to being done, because even though these look hard, they're not at all. So here, I have my 15 here, again, my common base. So I'm going to take that 15, and I know that my solution is going to have a base of 15. And now I'm going to add 2 to negative 7, and 2 plus negative 7 is negative 5. Again, I cannot leave an answer with a negative exponent, so this becomes 1 over 15 to the power of positive 5. That 5 is bigger than 3, so I don't have to figure out what that is, and I'm done. So I hope that that makes sense to you, and we're going to look at another one here, or another type of problem. So in this next type of problem, the big thing that's different is you're seeing 2 different bases. And what that means is if you have 2 different bases in the problem, you're going to have 2 different bases in the answer. What I have right here is 2 to the power of 1. You always want to add in exponents. When you don't see them, you want to put them there. And anytime you just see a normal number, it has a power of 1. So that's 3 to the power of 1. So again, this 2 is the only thing that has a base of 2. There's nothing I'm going to be able to do with it. So in my answer, I'm going to have the base of 2. And that's just as it is. It's to the power of 1, but we don't write that. But now I am able to take my 3 squared and my 3 to the first power, and I can combine those into one base. So again, when I combine when I multiply like bases, the bases stay the same. So that's going to be 3 there, and 2 plus 1 is going to give us 3 to the power of 3. And this right here is my final answer here, because I have a situation where these are different bases and there's nothing I'm going to do here to combine them. All right, so let's look at the next one here. So I'm going to go in and add, I'm going to have 5 to the power of 1, 3 to the power of 1. So when I do that, I'm going to come here and I see that the 5 doesn't have anything I'm going to be able to combine it with. So 5 is going to live in my answer. But I'm going to be multiplying it by 3 to the power of 1 multiplied by 3 to the power of 7. So that base of 3 is still going to be there. And 1 plus 7 is going to give me 3 to the power of 8. So that right there, again, is my final answer. So we're going to look at this last one in this row. And again, this is just 9 to the power of 1 and 8 to the power of 1. So I look here, I've got a 9, a base 8, and a base 8. So my 9 will stay as part of my answer, and then 8 to the 6th times 8 to the 1st is going to be 8 to the power of 7. Again, 2 bases in the question, 2 bases in the answer. So I get 9 times 8 to the power of 7. So in these last 2 problems here, all we're really doing is applying the rules that you've seen throughout this entire lesson. So I've got 2 bases in the question, so I'm going to have 2 bases in the answer. So let's start here with my base of 5. So when I start with my base of 5 here, I know that I can actually multiply these together, and the base of 5 stays the same, but it is 5 to the power of 8 plus negative 4. Well, 8 plus negative 4 is equal to positive 4. So that is going to be 5 to the power of 4. Well, these 9s are going to be their whole separate problem, or where it's going to be its whole separate term here, because we're going to be multiplying by a different base. So here I've got 9 squared, 9 to the 3rd, and 9 to the negative 1st. So here I need to multiply all 3. Well, my base of 9 stays. It's in the question, it's in the answer. But now I have 2 plus 3, and 2 plus 3 is 5, and then 5 plus negative 1 is equal to 4. So in this question, that has to be my final answer. When I have 2 different bases here, there's nothing else I can do to continue to simplify. That's it. All right, so here we go. So in this one, and again, this is our last one here, we have two different bases. So we're going to start, I guess, let's just start with the 6 because that's the first thing we see. So we know we can multiply 6 to the 5th by 6 to the negative 4th by 6 to the negative 1st. Well, I know my base of 6 stays here, and then I add 5 plus negative 4. Well, 5 plus negative 4 is 1. So now I have 1, and I do 1 plus negative 1. Well, 1 plus negative 1 is 0. So when I multiply 6 to the 4th by 6 to the negative 4th by 6 to the negative 1st, I end up with 6 to the power of 0. Well, we should all know what that is, but we're not going to deal with it quite yet. Now let's go look at our 2's here. So here I'm going to have 2 to the power of 2 and 2 to the power of 3. So when I multiply like bases, again, the base stays there, and I add my exponents. So 2 plus 3 is going to give me 5. So I have 6 to the power of 0 times 2 to the power of 5. Well, anything raised to the power of 0 is just equal to 1. So this is 1 times 2 to the power of 5. And we know that anytime you multiply something by 1, that doesn't matter. So it is just 2 to the power of 5 as your final answer. So the only time that you're going to have a situation where you have two bases in the question and you only have one base in the answer is in a situation where some of the like terms add up to 0 and it just becomes 1 because anything to the power of 1 is equal to 0. So what you're going to do, all right, so at this point, if you're watching this video, you should have already done this Monday check-in. You should have already watched this video. If you took this quiz without watching the video, I know because you did, it's ridiculous. I reset it. It should not take you very long. You need to watch the video. Otherwise, you're not going to know how to do this stuff. You did not click this. You clicked something that said Tuesday instructional video on exponent rules multiplying like bases, and that's how you got to this video. So now what you're going to do is either today, if it's Wednesday, if you didn't get this done yesterday, because this video did come up sort of late, forgot to record the Zoom class, but you should have been in Zoom class. So if you, either today or tomorrow, you need to do the Wednesday work, multiplying exponents with like bases. So again, that's your Wednesday work. And then Thursday, you have another little video on another rule, and then another little skill check. So exponents should not be overwhelmingly complicated. We're not going to get these weird word problems. We're not going to have scary, strange things happening. If you watch the videos and then you come to Zoom class, this should be really easy. But this is one of the most important rules or important parts of Math 8. This is the first year that we usually, when we start teaching, the first thing that we teach is exponent rules. So we would have learned this in September. So the order was different this year based on some things with the district, and that's why we started with transformations. But this is important stuff. So I really hope that you dig in and engage with this because this is going to come back in Math 1, it's going to come back in Math 2, and you don't know what your teacher's going to be like. You don't know what they're going to give you. So I want you to engage with this because you have it right here. So thank you for doing what you're supposed to be doing. And then hopefully you'll tune in on Thursday. It's actually, the video is already there, so you could keep working ahead. But everything you need for this week is there for you. All right, bye guys.